Assalamualaikum warahmatullahi wabarakatuh and good morning. Today I want to present about additive manufacturing. First and foremost, I want to introduce our team members. First is Muhammad FAKHRUL HAZMAN bin RASLI, I, Muhammad HAFIZI bin HARUN, Muhammad ASHRAF bin ZAMANI, Muhammad LUTFI NURHAN bin Muhammad ARIFF, and the last person standing is Muhammad NAZRIN SHAH bin Jahari. First, did you know about additive manufacturing? Additive manufacturing, or stand for AM, is the industrial production's name for 3D printings, a computer-controlled process that creates three-dimensional objects by depositing material usually in the air. By using computer-aided design, CAD, or 3D object scanner, additive manufacturing allows for the shape. These are built layer by layer, which is in contrast to traditional manufacturing that often required machinings or other techniques to remove surplus material. This type of the process that can be divided into seven. First is wet photopolymerization. Second is material jetting, material extrusion, binder jetting, powder bed fusion, sheet lamination, and the last is direct energy deposition, or in the word is DED. And the three first is the material parts indirectly for wet photopolymerization, material jetting, and material extrusion, and the rest is using material parts directly. And the first for wet photopolymerization is the process that uses a wet of liquid resin photopolymer to create an object layer by layer. And the mirror are used to direct ultraviolet light which cure each resin layer through photopolymerization. And the radiation using in the wet photopolymerization is UV, visible lights, gamma ray, X-ray, and electron beams. This wet process using a combination of two molecules that's called epoxy and acrylate by using UV radiation. The printing process is carried out with UV laser. We remove the liquid and the process is done by layer and by layer. This VAT process is very fast and quick process. Second is material jetting. Material jetting creates objects in a similar method to a two-dimensional inkjet printer. Material is jet onto a built platform using either a continuous or drop on demand (DOD), or instant in Malay is titisan secara permintaan approach. Material is jetting onto the built surface or platform where it solidifies and the model is built layer by layer. Material deposit from a nozzle which moves horizontally across the built platform. The material layer are then cured or hardened using ultraviolet process. Next is material extrusion. Material extrusion is the common additive manufacturing process used spool polymer which are either extruded or drawn through a heat nozzle which is mounted on a movable arm. The build melt material layer by layer from the bottom to up, as the nozzle moves horizontally and the bed moves vertically. The layer adhere through temperature control or chemical bonding agent. Next is binding jetting. Binding jetting or binder jetting is the technique used a 3D printing style head moving on X, Y, and Z axis. It is to deposit alternating layers of powder material and a liquid binder as an adhesive. Next is powder bed fusion. Powder bed fusion encompasses a variety of additive manufacturing techniques, including 5 types. First is direct material laser melting, DMLM, direct material direct metal laser sintering DMLS, electron beam melting EBM, selective laser sintering SLS, and the last one is the selective heat sintering SHS. Electron beams layer on the thermal print heads of used to melt or partially melt fine layer of material after the excess powder is blasted away. Next is sheet lamination. Sheet lamination can be divided into two technologies. First is LOM and UAM. LOM is stand for Laminate Objects Manufacturing, and UAM is stand for Ultrasonic Additive Manufacturing. And the first one is for LOM, is shoot to create item with visual or aesthetic appeal and use alternate layer of paper and adhesive. UAM uses ultrasonic welding to join with metal sheets. UAM can be used with various metals such as aluminium, such as stainless steel, such as titanium, and the character for sheet lamination is low energy, low temperature process. Alright, and the last one is direct energy deposition, or stand for DED, is additive manufacturing that can be used with a wide variety of material, including ceramics, including material, and polymer. Alright, a laser electrics or an electron beam gun mount on an arm, move horizontally, melt wire, filament, feedstock, or powder to build up material as a bed move vertically.
For the application of AM, it applies in aerospace and automotive, which is supplies some part like gears. Second, it applies in machinery industry, which is example like turbines and special machinery, and also in classic car part. For the third is it also apply in handling and robotic, which is all parts, some parts in robots it is used AM, and also it apply in medical tools and purposes. For AM, it's also apply in jewelry and biking parts. Alright, we continue to the advantage and disadvantage of additive manufacturing. Alright, okay, for the advantage, first is the complexity is free because it actually costs less to print a complex part instead of a simple cube of the same size. Alright, the second thing is variety is free because if a part needs to be changed, the change can simply be made on the original cut file and the new product can be printed right away. The third is no assembly required, which is moving parts such as hinge and bicycle chains can be printed in metal directly into the product, which can significantly reduce the part numbers. Alright, next is next is little scale manufacturing, which is we don't need professionals to do 3D printing because children in elementary school also have created their own figures using 3D printing process. Next is few constraints like anything you can dream up and design in the CAD software you can create with additive manufacturing. When you have CAD software, you can create using AM. Okay, less waste because only the material that is needed is used. There is very little if any material wasted. Using AM, there is little waste. Alright, next is infinite shades of materials. Engineers can program parts to have specific colors in their CAD files, and printers can use materials of any color to print them. Alright, for the disadvantages, first is slow boot rates. Many printers lay down material at a speed of 1 to 5 cubic inch per hour depending on the part needed. Other manufacturing process may be significantly faster. For the disadvantage is like it is slow rate. Alright. Secondly is high production cost. Sometimes part can be made faster using technique other than AM, so the extra time can lead to higher cost. The third thing is considerable effort in application design and setting process parameters. Extensive knowledge of material design and the AM machine itself is required to make quality parts. Alright. Next is require post-processing. The surface finish and dimensional accuracy may be lower quality than other manufacturing methods. Discontinuous production process. Parts can only be printed one at a time, preventing economic scale. Limited component size or small volume. AM is disadvantage is the component size is small, which is in most cases polymer products are about 1 cubic yard in size, while metal parts may only be 1 cubic foot. While larger machines are available, they will come at a cost. Poor mechanical properties. Layering and multiple interfaces can cause defects in the products. Okay, for the conclusions of additive manufacturing is additive manufacturing has shown us how it is as much as interesting way of thinking about manufacturing as it is a new way of constructing components. As computing systems have become more powerful, the availability of software to slice CAD models for layer by layer construction has paved the way for additive manufacturing. That's all from us. Thank you.